While I was away from this channel for years, something absolutely massive has happened in the world of software in the last 4 years. We are not talking about a small evolution. We are talking about ground up revolution. We now have an entire new layer of AI infrastructure that did not exist when I made my last YouTube video 4 years ago. In this video, we are going to break down exactly what this new AI-driven world looks like and what it really means for how we build tech. This isn't about just a new framework or a slightly faster database. The world here is changed. It's a fundamental shift. Just a few short years ago, if you have said RAG or LLM agent in a system design meeting, people would have had no idea what you were talking about. Now these concepts are entirely new, absolutely critical layer of infrastructure, and the engineers who know how to design, scale and operate these infrastructure, they are the most in-demand engineers on the planet right now. Let me take back you to 2021. If you were designing a large-scale distributed systems back then, your architectural conversation looked something like this. You had your client layer, a request comes in from a user device, it hits a load balancer, gets sent to one of many app servers, and that server would talk to a cache like Redis for speed, a database like Postgres, Cassandra, DynamoDB to store things permanently, and maybe a message queue like Kafka or SQS for background jobs, and maybe blob storage for files. The hard problems we talked about were: how do you handle 10 million concurrent users? How do you shard a database that's growing too fast? How do you design a feed algorithm that scales? These problems haven't gone away, but a whole new class of incredibly hard AI-specific challenges have just jumped to the front of the line. Now let me show you what changed. The first thing that appeared, and this is fundamental, is the model itself. A large language model. Billions of parameters running on GPUs, consuming enormous amounts of memory and compute just to answer a single question. But you can't just plug a model into an existing architecture and call it done. You need an inference layer, a system that manages how requests come in, how they get batched, how memory is allocated on the GPU, and how responses stream back to the users. This is completely new engineering discipline, and it's brutally complex. Then you need to give the model knowledge it does not have, because it was trained on data from the past. So we built something called RAG, Retrieval Augmented Generation, a pipeline that takes your documents, converts them into something called embeddings, stores them in a vector database, and retrieves the right context at query time. And now in 2026, the biggest shift of all, the agents. Systems where the LLM does not just answer questions. It takes actions, it calls tools, it browses the web, it writes and executes code, it manages multi-step workflows. Designing agent systems that are reliable, observable, and safe, that's the frontier problem right now. All of this is AI infrastructure, and none of it existed 4 years ago. Now let me give you the clean picture, the full AI infrastructure stack as it exists today. Layer 1, hardware, GPUs, networking, memory, the H100s, the NVLink interconnects, the InfiniBand fabric, the Rocky V2 network. That's the physical substrate everything runs on. Layer 2, the model, the LLM itself. Billions of parameters trained on trillions of tokens, the thing that actually understands language and reasons about problems. Layer 3, inference and serving. This is where most of the interesting engineering happens. How do you serve a hundreds of billions of parameter model to thousands of concurrent users? How do you manage GPU memory? How do you minimize latency while maximizing throughput? Layer 4, orchestration and data. RAG pipelines, vector stores, agent frameworks, tool calling, memory systems, the layer that connects the model to the real world. Layer 5, observability and operations, monitoring, tracing, evaluation, cost management, guardrails, because a model that hallucinates in production and costs you $50,000 a day is not a successful system. Each of these layers has its own deep engineering challenges, and we are going to go through all of them one video at a time. Now, if you are someone who studied system design the old way, the distributed databases, consistent hashing, cap theorem, message queues, I want to tell you something directly. None of that knowledge is wasted. In fact, it's your biggest advantage. Because here, what I have seen, most people building AI systems are either ML researchers who don't understand distributed systems, or software engineers who don't understand machine learning. The engineers who understand both are exceptionally rare and exceptionally valuable. The KV cache in an LLM inference engine, it's a caching problem. Same principles you already know. Scaling an LLM serving layer to millions of requests, it's a distributed systems problem. Same principles you already know. Designing a RAG pipeline, it's a data retrieval and indexing problem. Same principles you already know. The vocabulary is different, the components are new, but the thinking is the same. And that's exactly the bridge we are going to build together on this channel. If you are new here, subscribe. Every video in this series will go deeper than the previous one. If you are an old subscriber, welcome back. Drop a comment below. Tell me what part of AI infrastructure you are most confused about or most excited to learn. That will help me prioritize which videos to go deepest on. My next video is on how to design an LLM inference service. It is the foundation everything else builds on. Don't miss it. I will see you in the next one.